This is a video on scientific skills, revision for the upcoming half-yearly exam for Year 9 Science. This video should hopefully be revision. This isn't new stuff, I hope. It's more or less just a revisit of the basics of things like graphing in science and variables. So I'll start off with a table of values. So suppose I have a table like this. So suppose I have these measurements from going out into the field and going, sending down a probe underwater in some ocean. From 50 meters down to 200 meters, I took measurements of the temperature of the water. And I'm asked to graph this. Now, why would I graph this to begin with? Well, graphing things just makes it visually easier to understand what's happening, to look for trends, okay? You can look for trends, you see patterns in tables, but it's just nice to have like a visual aid. So tables are great, but in science, having graphs is much better. It's much more appealing to the eyes in terms of seeing what's happening, and you can work things out a lot quicker. So how do we graph this? Well, typically the first column of values, that's known as the independent variable. The independent variable in science is what you're changing. Okay, a variable is the thing that you either change, keep the same, or measure. Okay, so the water depth is changing, right? So I'm taking measurements at different depths of water. So that's the depth is changing. What I'm measuring is the temperature, and that's the dependent variable. What you're measuring. So the first thing when you see this in an exam, always remember that the first column is independent, second column is dependent. Just think of I as in I'm first, right? I come first. That's a good way to commit to memory what goes first. Okay, recognizing that, let's now plot. So using a pencil and ruler, hopefully, draw a set of axes. Okay, you've got an X and Y axis. X marks the spot of the treasure. That's how I think of it. And Y is vertical. Think of someone saying, why are you up there? So the independent variable always goes down here. In this case, it's the water depth. Okay, think of it this way, and always label your axes, I should mention. Okay, so identify which variable goes where. I can make like a checklist here. Number one, draw up axes. Okay, pencil and ruler. Step two, label, I should say identify where variables go. Step three, label axes plus units. Okay, the units of water depth in this case is meters. So water depth in the x-axis, why is that? Well, independent variable, think of I'm down here, okay, for independent variable. Okay, I for independent variable, that goes on the bottom axis. On the top axis, vertical axis, you've got the dependent variable, which is the temperature in degrees centigrade. I'm just going to put temp for now, degrees Celsius, because I'm running out of room. I can do it this way. Temperature. Okay, that's step three, very simple. Step four, choose appropriate scale. A lot of students get this a bit wrong. They get the labeling right and everything, but just the scale for each axis. So water depth, choose an appropriate scale. You're not going to go up by ones, okay? That's going to take some time. You're not going to go up by 20, obviously, because it starts at 5. So I would go up by 5. Actually, in this case, I would go up by 3. Okay, choose an appropriate scale. So start at 0, 3, 6, 9, 12, 15, 18. Now, I didn't go up by 5s because then I wouldn't have much of a scale to use. So you have to use most of the graph that's provided, yeah? It's an important note here. Use most of graph space, typically 3/4. Okay, around 3/4. So about 75% of the graph, right? You're not going to draw a graph that's too small, or too big, something that's just right. So go up by 3s on the x-axis, on the y-axis. Quite simply, you can go up by 40. So 4, 8, 12, 16, 20. Extend this out a bit. 24. Okay, perfect. So appropriate scale. And now step 5 is to plot. So let's plot these values. And the way you plot is you start from the bottom. Okay. Don't start from the middle. Don't start from the end. Start from the top. So at a water depth of 50 meters, temperature is 15 degrees. So 50 meters, 15 degrees. My apologies, I got these the wrong way around. So, oops. I'm uploading as to what I'm doing. It's a bit late. Mine isn't working that well, apologies. So this should be 40, 4, 8, 12, 16, 20, 24. Okay, equally spaced. In this case, I'm not doing it equally spaced because I'm being a bit sloppy. 3, 6, 9, 12, 15, 18. Apologies for that once again. All right, so water depth 50 meters, temperature is 15. So 50 is about here. 15 is about there. Put a dot. Okay, going down now, 100 meters, 12 degrees. 100 meters, 12 degrees. Your graph is going to be a lot better than mine, I'm sure, if you're doing this with me. 150 meters, 10 degrees. And 200 meters, 5 degrees. Okay, and then you connect the dots. And the graph makes sense, just a sanity check, because with increasing water depth, the water temperature decreases, okay? And you should also give your graph a title. In this case, it'll be water depth, I should say, water depth meters versus temperature degrees Celsius. Okay, you must put the units in the title of a graph. Particularly senior students, some of my senior students haven't been doing this, and that's not good. You need to have units, okay, particularly in exams like the HSC. I take it seriously. So that's how you graph something like this. Okay, and I've used the line graph because the data is continuous, which means it can technically go on forever, theoretically, as deep as you want. Or at any height, you can have, I don't know, 50.1, 50.2. You can have an infinite number of points, right? So that's why a line graph is appropriate. Let's do another example. Let's do car type. Number in street. Toyota, Merc, Beamer, Subaru, Ford. Suppose I've got this data from some street. Okay, there's 5 different cars observed in a street, and they're the number in the street, number of cars observed. The first thing to do is identify what type of graph to use. You would use a column graph because the data is discontinuous in this case. It's categorized. Okay, just like the number of students in a class, okay, it's finite. You've got a finite set, limited set. Same thing here, you've got a limited set of cars. You don't have an infinite number, so you use a column graph. Step 1, draw up the axes. Step 2, work out where the variables go. So this is typically the independent. Okay, remember, I'm first for independent. That's the dependent variable. So cart type goes down here. There's no units in this case, so no need to worry. And number and street goes here. No units as well, it's just a number. And the title can be for the graph car type versus number in street. Let's choose an appropriate scale for car type. Let's go in the order that's presented: Toyota, Merc, Beamer, Subaru, Ford. Okay, choose an appropriate scale. Let's go up by twos. So starting at 0, 2, 4, 6, 8, 10. I should mention 12. It's nice to always go beyond the numbers. So 10 is the maximum, but I like to go up 1 as well. Okay, typically it's convention in science, in physics anyway, where you go 1 beyond in terms of graphing. Sometimes graphs don't have that, but I prefer to have that. It's just nice to give a nice spread, to see what's happening. Potentially to even extrapolate, to predict what's going to happen later on as well, in some cases. But anyway, okay, Toyota, there's 2. So what you do is using a pencil, of course, and making sure the scales are evenly, the axis evenly, you've got even spread between the names here and the numbers, of course. There's 2 Toyota, so draw a box using a pencil and ruler like that. Okay, same width for all of them. Up to 2, and then Merc, there's 5. So all the way up to 5, which is halfway between 4 and 6. Beamer, there's 10, so all the way up to 10. Subaru, there's 4, so up to 4. And then finally Ford, there's 6, up to 6. And that's how you do it. Okay, these are typically 4 markers. 1 mark for the title, it's just to give you a view, a lens into the world of marking. 1 for the title, 1 for the actual plotting, 1 for labeling the axes correctly, and 1 for the correct scales. Okay, so 4 marks, and that's how you graph. I'll give you some questions now to do. Hopefully my students are watching this and actually do them. So questions, I'll give you question 1. So graph the following. Just give these 2 a crack and be careful as to what type of graph you have to use.